Okay, we're going to test out a newly acquired uh, oil pressure temperature sending, oil pressure and water temp sending unit. I've got it hooked up. I'm using a 9-volt battery as a source. That would be representing the low power setting if on a car in case your car battery was weak. What I'm trying to do is, besides test the functionality of it, I also want to see how well it regulates, so that if you had if it was just a straight resistance load and runs the meter there, it would vary what it would say about a particular resistance, which I'm going to use a test light here to represent based on what the battery voltage is. So let's test it with a weak battery. It is a 9-volt battery, and I'm going to put the resistance load, which is going to be this test light, and it's simulating, let's say, an oil pressure sending unit to ground. I'm connecting it to ground now. You can see the light lights up on the test light, showing that it's flowing current. And now we're going to read and see how what the gauge says. Again, now this is with a 9-volt battery. Now, ideally, since I have a fixed resistance load on this light bulb, this should give you a fairly consistent reading, assuming this was like an oil pressure sending unit, regardless of what the battery voltage is. You want to know what the oil pressure is. You don't want to know what the battery voltage is. So, if these have a built-in voltage regulator, which duty cycles based on how much voltage there is. So right now you can see it's a little over, the oil pressure is indicating a little, maybe 2/3, just a little over half. And again, that's on a 9-volt battery, right? And you'll notice the light's not flashing here. That's important. That means there's no duty cycle. It's just drawing current and driving that meter, which means it's at the low end of its battery voltage, I presume. So now we'll take it and we'll substitute a stronger battery, which is going to be this three-cell LiPo pack, which is about 13 volts. Plug it in. We'll ground the unit again and see what it says now. Oops. I've got to get it on here first. Stand by. There. Now you can see the lights flashing. So it's basically duty cycling the current through the meter based on the higher voltage. I think there's a little bimetallic strip in there that heats up and opens and closes depending on how much current's flowing. So it wants a constant current to flow through there, and the way it does that is it duty cycles that bimetallic switch, opening and closing the circuit. I guess we're maxed out, and as you can see there, it's about the same. So even though we went from a 9-volt battery to a 13-volt battery, the voltage regulator, which is in operation based on this, is clearly limiting that current by flashing on and off. I mean, theoretically, if it was constantly on, then that's probably not a really good bunch of regulation going on. You're obviously at the low end because it's not duty cycling at all on a 9-volt battery, just 100% on. But you get that point. Anyway, that's how you can test it. I think I've got it currently set up to run through. I think that's the oil one. If I want to test the water temp, I have another lead here. This green lead goes to the water temp sensor. I'm going to use the test light again to represent the resistance load. It's a temperature, like a thermistor in there that changes resistance based on current. And we'll do the same thing. Now this time we're going to be testing the water temp. So what you want to do is you just want to make sure those meters work. And you can calibrate them crudely if you'd like by just comparing the actual water temp in the radiator to what this thing indicates. And you can put a manual oil pressure gauge if you want to check the oil. But I mean, they're not precision instruments. You're basically just looking to get a ballpark figure. You can see the calibration just says 0 to 90, and you just guesstimate where you are. So There you go. But as you can see, the flashing indicates the voltage regulation is in process, and it's indicating now. I don't know. If I had to guess, I think the middle is 180, so I'd say maybe about 190, 195 right there. Again, we'll switch the battery out to test out the. I can't remember which one of these, but I have two 9 volts out here. Which one is good? That's a good one. Don't look it up backwards. Working it back up again. Now this time no more flashing, so it's taking everything that battery's got. There's no real voltage regulation going on. It's not duty cycling at all, but hopefully that battery voltage would be high enough. I did try it on a lower powered 9 volt. This 9 volts a little bit weak, and you can clearly see that it does not go as high, but it's going right to the same 190. Okay. So regardless of the battery voltage within a reasonable range, this thing will indicate the same values given a particular fixed load. Just for fun, let's put on this low. I know this one's weak, okay? So let me hook this one up and I'll show you what I mean. This battery is definitely subpar, and the light stays on, but you'll see at this point we've gone beyond its ability really to regulate. And I don't think it'll go as high now. In other words, now the battery is the limiting function, no longer the voltage regulator. And it's obviously below some kind of threshold where it will work consistently. So it's just going to stop at about halfway point. I don't think it'll go any higher than that. But again, this battery is weak by comparison to that battery. So, I mean, that's just the way it is. So that's as high as it's going to go. Let's see if we can see that weakness just for fun. Let's compare these three with a test light. That's a pretty high amp test light. Let's see what it says with this one. You see that brightness? That's with the weak battery. I think that's a strong battery. I've gotten lost now. Here's the other battery. Oh yeah, there you go. That's obviously the strong battery. And this is by far the strongest battery. Okay? So you can get it, you can see the difference, even though there was a pretty substantial difference between these two batteries, a 9 volt and a 13 volt. They indicated the same. We had to get down really low, this really weak battery, before it really started to affect the results of the meter. Anyway, that's the test setup. That's how it works. It's a pretty straightforward thing. It has a power lead and a ground lead and then a signal lead, and you just connect the signal lead to ground in order to activate the gauges. There's also two independent leads that are for the little light bulb inside. For that one, you get a positive lead and I think a variable ground, so you can dim it. So that's why it's. Oh, the other thing that's very important with this is that the case be grounded. I don't know if that's significant or not. Yeah, the case is grounded through the connection. So anyway, that's how it works. I just want to show you the newly acquired gauge. I really like these things. You know, it's kind of cool that they have. I like the mechanical voltage regulators. There's no computers involved here. You know, none of that nonsense. It's just this will work until it doesn't work because of some mechanical breakage, not until some computer capacitor spills its guts and smokes a PC board or something like that. And that's why I think things like this will be on the road long after the computer stuff's no longer on the road, because when everything's controlled by some central computer, as soon as that central computer is no longer available or no longer fixable, and with with so many things being with surface mount stuff, those tiny components, there's no through-hole manufacturing anymore. It's pretty much impossible to repair things at the component level. I don't know how modern cars and with modern computers are going to stay on the road. Maybe that's the whole point. They won't stay on the road more than a few years as those computers start to fail and there's just nobody who can fix them. This kind of stuff, I mean, that technology has been in existence, you know, since the 19th century type technology. Simple batteries and electromagnetism and resistors, nothing to it. Anyway, that's it for now. Thanks for watching. Bye.